specifically, we are going to talk about the reciprocals to cosine and sine. So we've already graphed sine and cosine. We're going to graph the reciprocals first, okay, using knowledge about reciprocals to help us graph. And the other function that we're going to graph is tangent. Now, tangent is a little bit different than sine, cosine, cosecant, secant. It has one major difference, and then its framing method is a little bit different. So I'll have another blue sheet that I'll give you that you can put into your notebook when we get to tangent. But just so you're aware, I'll have you graph tangent, but we won't graph cotangent. So just kind of be aware of that. Cotangent is very similar to tangent, and then it uses the normal framing method, whereas tangent does not. So we're only going to redo one of those, which is tangent. Okay, so we're going to graph the other trig functions. I'm going to start with cosecant. I'm going to ask you this question. What do you know about cosecant in relation to the other trig ratios? It is 1 over the sine of x. So it is the reciprocal to sine. So I'm going to use some knowledge about the graph of y equals sine x to help me with the graph for y equals cosecant x. Now here's the really nice thing about graphing cosecant and secant. Nothing changes really in the setup work that we do. So you know how for sine and cosine we first practice doing amplitude, period, and starting point? We're basically going to do the same thing with cosecant and secant. The only change to that is I'm not going to call it amplitude anymore, because technically it's not going to be the same as the definition of the amplitude, half the distance from the min to the max. We don't have that anymore. Okay? So when I do my work now, I'm just going to say the absolute value of A. If I was graphing y equals cosecant x, the absolute value of A would be 1. The period would be 2 pi over 1, which is 2 pi. Okay, if the period of sine is 2 pi, the reciprocal cosecant is going to have the same period, 2 pi over b. Okay. And the other thing that we did always was our starting point. In this case, our starting point is 0, 0, right? So we're graphing essentially the parent function for cosecant. So I'm going to take those three things, just like we always did, and put them onto my frame. So you draw a frame. Over on the left side, we're going to put the starting point right in the middle, 0, 0. And then just like I've always done, I'm going to start with what normally was the amplitude. Here I'm just going to call it the value of A. I'm going to add and subtract A from the y coordinate of my starting point, okay, to build my frame vertically. So 0 plus 1 is 1, and 0 minus 1 is negative 1. And then I will take my x-coordinate of my starting point, which is at 0, because I have no left-right shifting. And I'm going to add my period to that. So 0 plus 2 pi, my endpoint should be 2 pi. This is my property. Sure. Thank you. Fine. You let me this again. So add 2 pi. That gets me to an endpoint of 2 pi. And then to get the middle point, add half of the period. So I'm at pi, and pi over 2, and 3 pi over 2. This is not a very exciting frame, correct? Are we okay with this? Okay, now, normally we looked at the unit circle, and we would just go ahead and go through all the angles, and we would pick out their sine values. So at angle 0, the value of sine is 0. That's the y-coordinate. At pi over 4, the value of sine was square root 2 over 2. At pi over 2, the value of sine was 1, because the ordered pair was 0, 1. So if we're talking about cosecant now, what we want to do with those y values is use their reciprocals. So let me ask you this. If we're starting at angle 0 and the sine value is 0, what is the reciprocal to 0? Undefined. That means that on our graph, wherever sine would have been 0, we will have asymptotes. What is the reciprocal to... What is the reciprocal to 1? 1. So anytime the sine value is equal to 1, the cosecant will share that same value, right? So when you're thinking about the sine graph and the cosecant graph will share points whenever the value of sine was 1 or -1, right? They're going to share those same points. So in order for me to draw my cosecant graph, I'm going to very lightly sketch in my sine graph. I'm going to use dotted graph there. And I'm going to use those points, those 5 critical points on my sine graph to help me decide what should be happening on my cosecant graph. So remember we said anytime the sine was equal to 0, I would have an asymptote. So there are 3 points in the graph of sine where you cross the midline of your frame. That's when it's equal to 0, so you should draw an asymptote. So I have an asymptote at x equals 0. I have an asymptote at x equals pi. And I have an asymptote at x equals 2 pi. For the values when sine was equal to 1 or -1, that's like the min and the max of our frame, those values are going to be shared by the cosecant graph, so I can draw a point at those same locations. So I should have a point on cosecant at pi over 2, 1, and I should have a point on cosecant at 3 pi over 2, -1. Now, to build the rest of cosecant, I'm going to pick an easy angle to work with for sine value, and that's going to be pi over 6. If I asked you, what is the sine of pi over 6, you would tell me what? 1/2. The y-coordinate at pi over 6 is 1/2. So think about where pi over 6 would be on this frame, somewhere in between 0 and pi over 2, closer to 0, right? And somewhere over there it's equal to 1/2. What's the reciprocal of 1/2? 2. So if we were graphing cosecant, then that point would show up above the frame. And the same thing happens as you go around the unit circle when you get to 5 pi over 6, right? At 5 pi over 6, your y value would have been 1/2. If you were, instead of graphing the sine value and you were graphing cosecant, you would use its reciprocal, which would be 2. And so in between your asymptotes, you're going to get some U-shapes trapped between the asymptote. You don't normally need to draw those extra points for me. It's just to give you an idea of why we have a U that opens up and why we have a U that opens down. Because those fraction values that were less than 1, when you do a reciprocal, they become improper. So they become more than 1. They're outside of the frame. Does that make sense?
So it's just a bunch of U's tangent to the min and max of the sine function.
Yes. Now, the one thing I'll say is, like, I will always call them U's. They are not parabolas. Parabolas cannot be trapped between two asymptotes. Parabolas have very special properties that we'll talk about later when we do conics, and those are not parabolas. Okay, so things I need you to be able to do with cosecant and secant. I need you to be able to label the period. That's super easy. Nothing changes. 2 pi over b. I need you to be able to do the starting point. Again, super easy, nothing changes. C over B comma D. You should be able to label range. So think about the range of this graph. What is the lowest value of this graph? Negative infinity, right? So you got to start, if you're doing range here, you've got to start at negative infinity, and you go all the way to what value? Negative 1, and you are negative 1, so that should be negative 1 inclusive with a bracket. And then you skip a little bit of space, right? There is no cosecant graph until you get to 1, and you go to positive infinity. In union with 1 to positive infinity. So cosecant and secant are always going to have that funny range where you have to give me range in two parts. Okay, there'll always be a gap if you think about what Mason said about the reciprocal graphs being tangent to the max and mins. Okay, so you always have that gap in between where the sine function would have been. And the other thing that you should label are going to be the asymptotes and the points. So I did that as I graphed. X equals 0, x equals pi, x equals 2 pi, and then I labeled my two min and max points for my use. Okay, so I would like to see those. You're still labeling like 5 things on the graph. It's just that they're not all points anymore. 3 of them are asymptotes, 2 of them are points. Does anybody have any questions about that cosecant graph? Yes, ma'am.
Can you go over how to find the asymptotes again?
The asymptotes will always occur anytime the original function would have been 0. Because when the original function would have been 0, the reciprocal of that will be undefined. So when I'm going in and I'm looking at, like, that's why I've sketched my sine graph. The places where those parent graphs, sine and cosine, are equal to 0 happen at the midline of the graph. So basically, any of the points where sine crosses the midline turn into asymptotes. And that will be true for secant as well. Anywhere you're crossing the midline, draw an asymptote. Okay, so I've got another slide where we'll quick draw secant. Okay, I won't spend as much time talking about secant because it's basically the same idea. All right, instead, this time it's a reciprocal to cosine. Okay, so this is the reciprocal to cosine. So I'm going to go ahead and lightly sketch cosine's graph. And I'm going to use that to graph the secant. But all of those introductory bits of information that we use to frame, those are all going to be the same. The absolute value of A is 1. The period is 2 pi. The starting point is 0, 0. So as we label our frame, it's going to be the same frame we saw for cosecant and the same frame we saw for sine and cosine when we did those the first time. And so I'll put my starting point as 0, 0, add and subtract my A value. And then add my period and break it up on the horizontal. The only thing you'd have left to do here is decide where you have asymptotes and where you actually have the U-shaped graphs. So remember Lily's question about the asymptotes. Those are going to be formed anytime the cosine was equal to 0, which when you're looking at your vertical axis of your frame, that's at the midline. So now anytime the cosine crosses the midline, that's where I should have an asymptote. X equals pi over 2. X equals 3 pi over 2. At the mins and max values of cosine, that's where I have the min and max of my u's. Okay, so up here at the top left corner, I'm going to have half a u going to that asymptote. I usually don't draw the other half of the u. It does not bother me to have half a u. If you would prefer to draw the other half of the u, just know that you're going to have more than one period shown. But I usually only draw half of it. And that's at 0, 1. I share the point pi, comma, negative 1, and I'll have a u in the middle that opens down. and then share the point 2 pi 1. And again, I'll only draw half the U. If you draw the whole U, it does not bother me. But I could literally take my picture and then just copy and paste it, and then I would create all the U's instead of one period. So you should be able to do the same thing for secant that you did for cosecant, and it's really the same thing that you did for sine and the same thing that you did for cosine. So there's not a lot of difference there. And I would do range again. It's going to be the same thing in this parent graph. So negative infinity to negative 1, inclusive, in union with 1 to infinity. Okay, so I'm going to give an example that we'll do. I'm going to have you do some of the setup pieces. Okay, so think about the absolute value of A. I'm not going to call it the amplitude because the amplitude was half of the distance from the minimum to the maximum. Notice secant and cosecant don't have mins and max of the functions because they go to negative infinity and positive infinity. So that definition doesn't fit anymore. Okay. It does have mins and max of the views though. So I'm going to find the absolute value of A, we'll find the period, and we'll find the starting point. And I want you to do those things for y equals negative 2 times cosecant of x minus pi over 4.
We don't have to graph this.
We are going to graph it, but I'd like you to at least do the setup pieces. So can you apply the same things we had done for the other graphs to cosecant? And if you get those done and you want to start drawing your frame, maybe even attempting to label it, you could do that. That'll be okay with me. Okay, Sammy, can you tell me the absolute value of A? And Maddie can give me the period for this new function. 2 pi. It is 2 pi over 1, our B value, right? And Amy, can you give me the starting point? Pi over 4 comma 0. Would you please check your starting point and make sure you have positive pi over 4? Because when you pull out, see it looks like the opposite. And that would be positive pi over 4 over 1, which is still just positive pi over 4. Thank you. So if I were drawing the frame, I would start at my starting point, pi over 4 comma 0. I would use Sammy's absolute value of A to build it vertically. So looking at the y coordinate of 0, I would add 2 and subtract 2. And then using Amy's starting point, I'm going to start my left side of my frame at pi over 4. That's the x coordinate. And now I've got to add Maddie's period. So pi over 4 plus 2 pi is 9 pi over 4. Because if you add 2 pi, you're adding 8 pi over 4, right? So pi over 4 plus 2 pi gets me to 9 pi over 4. Lily was initially saying 5 pi over 4. That's only adding 1 pi, which gets us halfway across, right? So 5 pi over 4. We're adding half of the period at that point. And then you might be able to look at that and just say, like, what's in between 1/4 and 5/4? What's in between 1 and 5? 3? Okay, they both flew away. So this will be 3 pi over 4, and this will be 7 pi over 4. You can also add 1/2 pi, because to get halfway across the frame, you'd be adding pi. To get half of that, you'd be adding half a pi. So pi over 4 plus pi over 2 is 3 pi over 4. Okay, and then your job is to draw a cosecant, and it is negative. So the parent function we're really thinking about is negative sine. If you, especially in the beginning, want to start by very lightly sketching those sine and cosines, just to figure out like where your asymptotes and u's will be, by all means go ahead and do that. The more that you do that, actually the less you'll need them later on, because you'll kind of get used to the pattern. And then I can draw the asymptotes anywhere sine would have crossed the midline. So pi over 4, x equals 5 pi over 4, and x equals 9 pi over 4. Notice how when I label asymptotes I use correct notation. X equals a number, like it's a vertical line. And then you draw in your u's and label your points. Okay, so we'll share a point down here. If you label this, you should have 3 pi over 4 comma negative 2. And then this is 7 pi over 4 comma 2. And then I've got cosecant. You should practice range. So always when you have these U-shaped graphs for cosecant and secant, you're always going to start at like negative infinity. What do we go up to here? It only goes to negative 2, right, because of the change in the A. So watch out for D's, which will be vertical shifts, and then also change in A's. That would affect your range. So we come up to negative 2, use a bracket, and then include positive 2 to infinity. Okay, so we're skipping over. There is nothing in between negative 2 and 2. Okay. That where we drew the original sine function with negative a, that's not part of this cosecant function at all. So, what do you think about graphing secant and cosecant? Not too terrible? Okay. Notice that you should still have 5 things labeled. Like we have 3 asymptotes and 2 points labeled. So I'm going to be checking those things when you take your quiz on, what day do I see you? Wednesday? Quiz on Wednesday. Problem set due Friday. I'm going to be checking that those things are there. I'm also going to be checking range. I should mention, I'm not going to ask you about domain for these functions. That's because domain is affected by what in these graphs? The asymptotes. And we can, and I can share this with you tomorrow, we have to write an equation or an expression that represents like skipping over all of those asymptotes, and I'm not going to ask you to do that.
For the cosecant, it's 3 asymptotes, 2 points, and then for the secant, it's 2 asymptotes, 3 points.
Mm-hmm. But you still have 5 things. Okay. Any other questions? Okay, the last thing that we want to talk about today is tangent. So I have a little blue sheet. This was on the back of your other blue sheet. I told you I'd give you a new one. They weren't supposed to be copied like that. So there's a couple of things that are different about graphing tangent. When you look at the very top of the blue sheet, you're going to see nothing different is about the general form. So it still looks like y equals a times tangent bx minus c plus d. So identifying a, b, c, and d works the same way that it did for sine, cosine, cosecant, and secant. Okay? And that's step 1. Identify a, b, c, and d. Notice in A it says identify A. Again, it's not called an amplitude like it is for sine and cosine because it doesn't fit the definition of an amplitude. But we'll still use it in the same way we used it to build our frame vertically. Okay. 1B says calculate the period. This is something that's different. So you're going to put a star next to 1B. Okay. And next to calculating the period, instead of 2 pi over b, it is just pi over b. I'll show you why on the next slide. So that's a big difference from tangent to the other graphs. C says analyze translations. That means left, right, up, down. And that really goes along with 2, which is identifying the starting point. And notice nothing changes there. C over b comma d. So I want you to think about, so far, the only thing that's different about tangent is period. Pi over b instead of 2 pi over b. Okay. Part 3, construct the frame starting at the starting point. Okay. 3A, put a star next to that. Highlight it, bubble it, something. 3A is different. Starting point should be in the middle of your frame. Okay. So that's new. Okay. That's the other big difference for tangent. 3B, use A to determine the top and the bottom. Already done that. Okay, that's not new. But 3C would be the other part of that new piece. Use the period to determine the length, and then in parentheses it says put half on each side. So instead of like really using the starting point as the beginning left side of your frame and just adding the period to the right of that, we're going to put the starting point in the middle of your frame, and we're going to add half the period on the right and half the period on the left. The reason is the tangent at 0 is undefined. And so if we let that be its starting point, which it would be for tangent x 0, 0, then you're going to have an issue. No, sorry, the tangent at 0 is 0. But you're going to have an issue halfway through. The tangent of pi over 2 is undefined. So halfway in your graph, you would have a single asymptote that cuts the graph into 2 pieces, and you never get to see a whole piece tangent. So we're kind of rearranging the frame only so you can see one nice smooth tangent curve. Okay, what that looks like. Okay, so here's some reasoning behind what we're doing. Okay, this is the tangent function on the unit circle. I know it's very small. You probably can't read everything. That's totally fine. What I have done is I have highlighted on the outside the different values of tangent. So at angle 0, tangent is 0. At pi over 4, tangent is 1. And then here's that issue right in the middle of one period, because we said the tangent's period was pi. We hit something undefined, which means we have to break our graph, pick up our pencil, and start over. Okay. In quadrant 2, I get new values. I get a -1 at 3 pi over 4, and back to 0 at pi. So what we're going to do is we're going to put our starting point, okay, right there at 0, 0. But instead of going forward 1 pi and having the asymptote break up our graph right here, we're going to go forward half pi and backwards half pi, and we're going to have asymptotes on either side of our frame. Okay, so the asymptotes are going to be on the left and the right side of your tangent frame, and you're going to get one nice tangent in the middle of them, which we'll draw here in just a moment. Okay? And the reason why tangent only needs pi units to repeat is the way that tangent is around the unit circle. It's the only trig function where you have positive in quadrant 1, negative in quadrant 2, positive in quadrant 3, negative in quadrant 4. So you run through positive, negative in 1 pi. And then you just repeat it again, positive, negative, positive, negative. So instead of needing 2 pi to make one new shape, you only need 1 pi. Okay, so here's the frames that you can put at the bottom. That yellow dot I've moved. So you need to make something, mark something in your frames at the bottom of that blue sheet that this is your starting point. And I'll put y equals tangent x here. So we'll graph y equals tangent x. Okay. If I did y equals tangent x, I could do the same things I've always done. The absolute value of a is 1. The period is pi over 1, or just pi. And the starting point is 0, 0. And the big difference is when you make the frame, you put your starting point in the middle. So that means this center point on the horizontal is 0, and then over here we're also at 0. Okay, so I can extend that to my vertical and horizontal axes. I can do the same thing that I did with A, which is add 1 and subtract 1 to build it vertically. And that will change depending on what the absolute value of A is. And then I want there to be a period of pi from the front of the frame to the back of the frame. So that means that I'm going to add half of that period to the right. So half of pi is just pi over 2. And then subtract that from the left. So it starts at negative pi over 2. And that corresponds to what I'm doing down here in the graph. Starting at negative pi over 2, and then going to positive pi over 2. Okay. Halfway between these two would be negative pi over 4 and positive pi over 4. And then I could use the unit circle to help me decide, like, what's what. What is the tangent of negative pi over 2? It is undefined, so I should draw an asymptote. So I have an asymptote at x equals pi over 2. What is the tangent at negative pi over 4? Negative 1. So I have a point at negative pi over 4, negative 1. Tangent at 0 is 0, 0. So that starting point is a point on our tangent graph. Okay. And at pi over 4, I'm at positive 1 for tangent. That's in quadrant 1, 45 degrees. And then when I get back to pi over 2, my tangent is undefined again. So I have a new asymptote at x equals pi over 2. And then I can draw the tangent function, which sort of looks like a cubic function. If you remember cubics from polynomials, sort of has like a bend in the middle of the graph. Okay. But it will approach the asymptotes on either side. One side's going towards negative infinity, the other side's going towards positive infinity, which means our range is all real numbers. Okay, it's connected in the middle, so if you want to write down your range, it will be all real numbers. Negative infinity to positive infinity. If tangent has a positive a, it is increasing from left to right. If tangent has a negative a, those two on the mins and max of the frames are going to flip-flop, and so then tangent will be decreasing from left to right. So in the other box, if you want to draw a picture of y equals negative tangent, it would look something like this. Okay, so it's just the flip-flopped reflection of that. So again, the whole reason for this weird thing about putting the starting point in the middle of the frame is to avoid your picture looking like this. Having a point like this, having an asymptote, and looking like this. And then you don't really get to see what tangent looks like. Okay. So we're just kind of shifting our frame so we can see that whole branch. Now I've got about 4 minutes left, so I want to do at least one example with tangent, just so you can see. Biggest issues are periods are different, and the method of graphing your frame is different. So here's my first one. Y equals 1/2 tangent of x over 3. Take a moment. Find these three things. The absolute value of A, the period, the starting point. The same thing you've been doing since last Thursday. Lean across the aisle, tell your shoulder buddy, the person across the aisle, what you got. Yeah.
You have to have those orders you go, and then you have like, one side of the
Okay.
Lexi, what did you get for absolute value of A?
Half.
1/2? Callie, what did you get for the period? 3 pi. It's pi divided by 1/3, so you're multiplying by the reciprocal, which is 3 pi. And what you get for the starting point, Ethan?
0,0.
Okay. Remember, when you go to frame this, you can put the starting point in the middle. It is the only graph that we're going to do this for. We would not do this for cotangent. Okay, we're not going to graph cotangent, but cotangent would go back to the old framing method. The only thing different about cotangent would be its parent shape and then its period. Okay, but it would go with original framing method. If my A value is 1/2, I should add 1/2 and subtract 1/2. So I'm going, from those values, but I know that's not the end of my range because tangent increases towards positive and negative infinity. For my period, if it's 3 pi, I want to add half of that to the right, so I'll just put 3 pi over 2. And then put half of that on the left, so negative 3 pi over 2. So now the full distance is 3 pi. This would be negative 3 pi over 4 and positive 3 pi over 4 if you need to practice your labeling for frames. And then I could draw an appropriate tangent graph. Thank you for your attention. I know that's a lot of information today. Please work on your assignments and come in with questions. You have a quiz at the end of next class. Yeah.
Could you go back a slide?
In a minute.
This copy. On this one. Know how much? Oh, yes. On this
Hang
one.
on.
Test physics. Did you have the green one or the yellow one? Yellow.